Seafood HACCP course presentation. 123foodhandler.com. Chapter 3. Fish and Fishery Products Hazards. In this chapter, you will learn about food safety hazards that have been associated with seafood and seafood products and are considered reasonably likely to occur if not subject to appropriate controls. Remember, hazards include a biological, chemical, or physical agent that is reasonably likely to cause illness or injury in the absence of appropriate controls. Undesirable conditions may not impose a particular food safety hazard, but they are subject to other regulatory controls and prerequisite requirements, like GMPs and sanitation control procedures. Examples include insects, hair, filth, spoilage, economic fraud, and violation of regulatory food standards not directly with and related to food safety. Potential seafood safety hazards can be grouped into three categories: biological hazards, chemical hazards, and physical hazards. Biological hazards can involve things like bacteria, viruses, parasites, yeast, and molds. Microorganisms that can be pathogenic and cause foodborne illness are bacteria, viruses, and parasites. Pathogens versus spoilage organisms. Biological hazards equals pathogens. Pathogens are microorganisms that result in a potential health hazard. Spoilage organisms are not biological hazards. They may affect quality, but not safety. Examples are yeast and molds. There are a couple ways people get sick from food. Remember, we are trying to prevent illness and injury. The ways people get sick from food are foodborne infection and foodborne intoxication. Let's take a look. Types of foodborne disease. Infections. Infections occur when we ingest live organisms and the pathogen is viable and multiplies in our body. Things like salmonella and listeria. Intoxications happen when we ingest toxins. Certain bacteria like Clostridium botulinum and Staphylococcus aureus produce toxins in or on the food. And there are other naturally occurring toxins in shellfish and other fish, like histamine and saxitoxin. According to the CDC, approximately 48 million people get sick from food every year. 128,000 of those are hospitalized, and 3,000 die. Have you ever been sick from food? Did you go to the doctor? Let's take a look at actual versus reported foodborne disease outbreaks. First, a person becomes exposed. Then a person becomes ill. Here's where things go awry. Some people seek care and some people don't. Some of those that seek care give off stool samples and some don't. Some of those samples are sent to labs and we can actually confirm a pathogen or illness. If that illness is confirmed and it's deemed an outbreak, 2 or more people have gotten sick, that information is then reported to the CDC and goes in the national database. Have you ever been sick from food? Did you go to the doctor? Out of the data that we have from CDC and health departments or local regulatory agencies with regard to outbreaks, most frequently people get sick from foods from an animal origin, like seafood. But more and more lately, people are getting sick from contaminated fruits and vegetables. The most common factors contributing to foodborne disease outbreaks are improper storage and holding, inadequate cooking, poor personal hygiene, cross-contamination, improper reheating, and poor storage practices. Well, like we talked earlier, there's a couple ways we get sick from food. It's going to be an infection or an intoxication. The pathogen or toxin must be present in the food. In some cases, the pathogen must grow in the food to high enough levels to produce an infection or toxin. Some pathogens like E. coli have very low infectious doses. Parasites and viruses do not grow in foods. They need a host to multiply. Food must be ingested and survive the digestive tract. Our stomach has a very low pH, but some pathogens must establish and multiply in the body. Remember, with seafood, we have to be mindful of food safety from the boat to the throat. Seafood products are commonly eaten raw, like oysters, clams, and conch and sushi. Seafood products, pre-cooked and frozen shrimp, smoked fish and pickled fish, fried crab meat, and pasteurized surimi or fabricated seafood analog, common ready food. Must always be mindful of time, temperature abuse, and cross-contamination with these products. Many of the bacteria we are up against are ubiquitous in the environment. They don't necessarily have the conditions that favor their growth, so we must understand what enables bacteria to growth and continuously keep them in the lag phase and not allow exponential growth. What bacteria need for favorable growth is fat tom. F stands for food, nutrients from seafood. A stands for acidity. Bacteria prefer neutral to slightly acidic pH. Bacteria need time, more than 2 hours above 70 degrees. Bacteria need temperature. Temperatures between 40 and 140 are favorable to bacteria growth. Bacteria need air or no air, depending on the organism. Bacteria need moisture. Water is abundant in seafood. Let's take a look at groups of bacterial hazards. We have spore-forming bacteria and non-spore-forming bacteria. Spore-forming bacteria like Clostridium botulinum, Bacillus cereus, and Clostridium perfringens have the ability to protect themselves when the conditions aren't favorable, too dry, too hot, too cold. They can become a spore. Non-spore forming bacteria like Listeria monocytogenes, Salmonella, Shigella, pathogenic strains of Staphylococcus aureus and Vibrio species, and other species like Campylobacter jejuni and Yersinia. They are not able to withstand rigorous conditions like high heat, dry conditions. In the next few slides, let's take a look at some controls for various bacteria. Some controls for Clostridium botulinum in seafood is to destroy spores during processing using thermal processing techniques. Other techniques include prevent potential growth by proper salting, drying, or pickling. Proper refrigeration, particularly for raw, non-frozen seafood packaged in aerobic conditions where limited oxygen is available. Packaging refrigerated fishery products in permeable film that allows enough oxygen exposure to prevent anaerobic conditions. Some controls for Bacillus cereus in seafood. Proper sanitation to prevent product contamination. Proper chilling rates for warm prepared food. Proper refrigeration for prepared, ready-to-eat food with extended shelf life. Some controls for Listeria monocytogenes in seafood. Proper sanitation to prevent product contamination. Proper refrigeration to prevent growth. Proper cooking. Prevent cross-contamination after cooking. Some controls for Salmonella in seafood. Proper sanitation to prevent product contamination. Proper refrigeration to prevent growth. Proper cooking. Prevent cross-contamination after cooking. Some controls for Staphylococcus aureus in seafood. Proper sanitation to prevent product contamination. Proper refrigeration to prevent growth. Proper cooking. Prevent cross-contamination after cooking. Some controls for Vibrio cholera, Vibrio perihemolyticus, and Vibrio vulnificus in seafood include product harvested from approved sources, proper refrigeration from harvest through processing, proper cooking, and consumption advisories for more susceptible populations. Control measures for biological hazards include prevent contamination of foods, keep them out, inactivate foodborne disease, kill them, prevent multiplication of pathogens, control them. We must always consider, are the hazards significant, already there? Are they enhanced, or are we introducing them? Hazards from viruses in foods. Viruses are not truly alive. Viruses exist everywhere. Viruses do not grow in food. Viruses do not spoil food. Viruses are transmitted by people, food, or contaminated water. Viruses cause illness by infection. Viruses. Hepatitis A virus causes fever and abdominal discomfort, followed by jaundice, which is the yellowing of the eyes and skin. Norovirus group, formerly Norwalk virus, causes nausea, vomiting, diarrhea, and abdominal pain. Gastroenteritis, headache, and low-grade fever may also occur. Norovirus is the #1 reason why people get sick from food in America. Primarily, viruses are going to come from a contaminated source or from a worker that is sick. So the controls include buying product from approved sources and thorough cooking. Although viruses tend to be a little more heat tolerant than bacteria. So focus on prerequisite programs like proper sanitation, proper hygiene workers, and of course, vendor specifications, vendor audits, things of that kind. Parasites are organisms that need a host to survive. Thousands of kinds exist worldwide, but only less than 100 types are known to infect people through food consumption. 2 types of concern from food or water are parasitic worms, like roundworms and tapeworms and flukes, or protozoa, which are microscopic single-cell animals. Methods of preventing transmission of parasites to foods by fecal contamination include good personal hygiene practices by food handlers, proper disposal of human feces, elimination of insufficient treated sewage to fertilize crops, and proper sewage treatment. Raw fish consumption is on the rise these days. So, because of that, illnesses due to parasites are on the rise too. Some parasitic worms of concern are Cryptosporidium parvum, nematoids and roundworms like Anisakis simplex, cystoids or tapeworms like Diphylobothrium, and trematoids or flukes. Some controls for parasites in seafood include proper freezing and proper cooking. Please read Chapter 5 in the Fish and Fishery Products Hazards Guide for more information on parasites. There are many naturally occurring chemical hazards in fish and fishery products. They're called biotoxins. Some biotoxins are in shellfish, and some biotoxins are in fish. Some naturally occurring toxins like tetrodotoxin occur in pufferfish, and some toxins due to decomposition occur in some fish. It's called scombrotoxin. Let's take a look at them again. Shellfish biotoxins include domoic acid, causes amnesic shellfish poisoning. Okadaic acid causes diuretic shellfish poisoning. Brevetoxin causes neurotoxic shellfish poisoning. Or saxitoxin causes paralytic shellfish poisoning. Shigawatera fish poisoning, or CFP, is common in reef-dwelling fish, such as barracuda, snapper. Tetrodotoxin is common in pufferfish. Scombrotoxin are common in many fish, like tuna, mahi, mackerel. Control for shellfish biotoxins in seafood. Only harvest approved shellfish products from approved waters. Please read the Fish and Fishery Products Hazards Guide, Chapter 6, Natural Toxins. Control for Shigawatera in seafood. Do not process certain fish harvested from waters that have been designated as potentially shigawatoxic. Please read Chapter 6 on natural toxins in the Fish and Fishery Hazards Guide for more information. There are naturally occurring toxins in some species that do not involve toxic marine algae, like tetrodotoxin in pufferfish. The control for tetrodotoxin is do not process certain fish, such as pufferfish, that have been designated potentially tetrodotoxic. Another naturally occurring toxin in seafood is gimplotoxin. Gimplotoxin is not from toxic algae. It's a naturally occurring toxin found in certain fish like escolar. The control for gimplotoxin is do not process certain potentially gimplotoxic fish. To learn more about gimplotoxin, read Chapter 6 in the Fish and Fishery Products Hazards Guide. Control for potential scombrotoxin in seafood. Temperature controls from the moment of harvest through processing, storage, and product distribution. Please read the Fish and Fishery Products Hazard Guide, Chapter 7 for more information. Additional chemical hazards in seafood include chemical hazards in seafood due to natural conditions, chemical hazards added intentionally but not properly, chemical hazards due to unintentional or accidental contamination, and allergens. Intentionally added chemicals, such as preservatives, nutritional additives, and colors, must be added to food under the allowable limits under GMPs. Controls for intentionally added chemicals in seafood include use proper type and amount of chemicals, label the product to inform consumers. Some controls for aquaculture drugs include only use approved chemicals in an approved manner, When necessary, only use certain controlled drugs in the manner prescribed by a recognized veterinary expert. Test for excessive residues in final products. For more information on aquaculture drugs, please refer to the Fish and Fishery Product Hazards Guide, Chapter 11. Unintentionally or incidentally added chemicals such as agricultural chemicals, cleaning chemicals, maintenance chemicals, prohibited substances and toxic elements like lead, zinc, and mercury, and polychlorinated biphenyls, PCBs. For more information on the allowable limits, please refer to Table A5 in the appendices in the Fish and Fishery Products Hazards Guide. Some controls for unintentional or incidental chemical contamination of seafood include proper use of chemicals, cleaning and maintenance compounds, proper location and monitoring of aquaculture farming operations relative to potential land runoffs and spraying of hazardous chemicals. Do not harvest from polluted or non-approved waters, and product screening relative to the source. Chemical hazards. Hazards may depend on exposure. Both long and short-term effects are known to exist. Based on studies, safe levels have been set. Laws and regulations are designed to ensure exposure levels are safe when chemicals are properly used. There are many laws and regulations that require that foods are safe and free of adulterants. The FDA and EPA enforce provisions of pertinent laws and regulations. Please review Appendix 5 in the Fish and Fishery Products Hazards Guide for more information on allowable limits. The Federal Food, Drug, and Cosmetic Act deems a food as adulterated if it bears or contains any poisonous or deleterious substance which may render it injurious to health, or if it bears or contains added poisonous or deleterious substances. Unavoidable poisonous or deleterious substances. Substances that are necessary in production of food or cannot be avoided with GMPs. FDA establishes tolerance or action levels for specific commodities. Examples given: aflatoxin, action level in foods is 20 parts per billion. Histamine, action level in seafood is 50 parts per billion. Allergens. There are over 180 foods that cause allergic reactions in certain people. These foods have proteins that induce an allergic reaction. Symptoms range from a mild rash to anaphylaxis and, rarely, death. 1 to 2% of adults have a food allergy. 5 to 6% of children have a food allergy. Of the 180 foods that cause allergic reactions, the top 9 cause 90% of those reactions. Peanuts, tree nuts, soybeans, wheat, milk, egg, fish, crustacean shellfish like lobsters, crab, and shrimp, and sesame as of January 1st, 2023. Keep in mind that molluscan shellfish are not included here. Allergens and food safety. Major concern is products containing an undeclared allergen. Not peanuts in peanut butter, but an undeclared peanut in a chili. Control of allergenic ingredients and prevention of cross-contact are essential for food safety. The number one reason why foods are recalled in the food industry is because of undeclared allergens on the label. Please read Chapter 19 in the Fish and Fishery Products Hazards Guide for more understanding and control strategies for allergens. Chemical sensitivities. A small percentage of the population is sensitive to certain chemicals like sulfites and colorings like yellow. Control is similar to allergens. For more information on control strategies for coloring and other chemicals like sulfites, please read Chapter 19 in the Fish and Fishery Products Hazards Guide. Intentionally added chemicals are safe when used appropriately, but can be hazardous if improperly used. Chemicals like pesticides, fertilizers, antibiotics, and preservatives end up in levels that are unsafe in the edible tissue of fish and fishery products. Regulations control the level in use and maximum allowable limits in certain chemicals in foods. Antibiotics and hormones. Use is controlled by the FDA. Veterinary drugs used must be approved by the FDA. If used appropriately, antibiotics and hormones pose no health hazard. Pesticide chemicals. Regulated by the Environmental Protection Agency, EPA. If used appropriately, pesticide chemicals pose no health hazard. Consider potential for pesticide residues in globally sourced ingredients. Lubricants and sanitizers. Lubricants and sanitizers pose no hazard when used in accordance with GMPs. Food-grade lubricants must be used where there is possible contact with food or food contact surfaces. SSOPs ensure residues of sanitizers pose no hazard. Let's talk a little bit more about allergen control and appropriate labeling. Ensure labels reflect all allergens. Carefully control the product labeling, formulation control, ingredient specification, and supplier control. Some allergen controls are going to be in your prerequisite programs. Some are going to be managed through the processing of food. Recognize the inadvertent introduction due to cross-contact, though. This could happen from different environmental exposures during processing or handling. Things like ineffective cleaning, dust or aerosols containing allergens, multiple food products produced in the same facility, use of the same processing line, or misuse of reworked food. Some control measures for inadvertent allergens are to minimize cross-contact by having separate storage areas, appropriate scheduling of production, careful and thorough cleaning, controlling traffic patterns, designing of equipment and systems, of course, adequate training of employees. Chemical control program prior to receipt. Under your prerequisite programs, make sure you're having supplier specifications to make sure that suppliers can help reduce the occurrence of potential chemical hazards like histamine and biotoxins and, of course, aquaculture drugs. Additional chemical controls prior to receipt. Develop specifications for ingredients, packaging materials, and chemicals. Qualify suppliers and audit operations. Obtain letters of guarantee. Upon receipt, inspect transportation vehicles prior to unloading. Inspect materials during unloading. Periodic sampling and testing. Verify the presence of a certificate of analysis where applicable. Establishment operations. Some additional controls for chemicals. Ensure that all chemicals are appropriately used in the facility. Designate responsibility for chemical receipt, storage, and use. Establish chemical control programs at the point of use. Audit and ensure adequate control of chemicals at all times. Chemical use and processing. Use only approved chemicals. Control chemicals at point of use. Cleaning and sanitizing procedures must prevent harmful levels of residues on food and food contact surfaces. Storage of chemicals. Store in tightly sealed containers. Store hazardous toxic chemicals in physically separated, locked enclosures. Store allergens to prevent cross contact. Cover packaging materials. Pesticide usage. Labels of pesticides used should be kept on file. Keep pesticide usage records. Limit poison baits to outside plant. And control the storage. Physical hazards. Any extraneous matter not normally found in food that could cause physical injury. Physical hazards. Foodborne injuries caused by a physical hazard usually involve relatively few consumers. Typically, result in personal injuries such as a broken tooth, laceration of a mouth, or choking. Food safety versus aesthetics. Potential food safety hazards from physical hazards are foreign objects or extraneous matter capable of causing injury, like glass and metal and rocks. Aesthetic contaminants such as insect fragments and hair and sand typically do not cause injury to consumers. Regulatory guidance. FDA Compliance Policy Guide 555.425, Foods Adulteration Involving Hard or Sharp Objects. Ready-to-eat foods containing hard or sharp foreign objects 7 to 25 millimeters in length is considered a hazard for the general public. Objects less than 7 millimeters may present a hazard if the product is intended for special risk populations like infants or elderly. Physical hazard. A contaminant in a product represents a physical hazard if it will result in an injury to the consumer. Usually hard, sharp objects between 7 to 25 millimeters. Sources of physical hazards include, but are not limited to, contaminated raw materials, poorly designed or maintained facilities and equipment, faulty procedures during production, improper employee practices, certain processes, operations, metal-to-metal contact by grinding or glass filling operations. Minimizing physical hazards. Raw material receipt. We must have material specifications, letters of guarantees, vendor inspection and certification, and periodic product inspection. Minimizing physical hazards. Facility. Attention to GMPs will ensure that the facility is not a source of physical hazards by properly protecting light fixtures, appropriately designed equipment, and adequate maintenance programs. Minimizing physical hazards employee practices. Adherence to GMPs, proper outer attire, no jewelry, no pins in outer pockets, employee training. Control maintenance work, inspect work areas for loose hardware and tools. Clean, inspect lines prior to restarting operations. Reconcile tools and parts inventory. Minimizing physical hazards during processing. Control measure for glass. Glass breakage program. Bottle invert. Shrouding. Glass handling line, etc. Control measures for metal. Magnets. Metal detectors. X-rays. Control measures for hard, sharp objects, perhaps screens and filters. Equipment used to detect and or remove foreign materials, magnets, metal detectors, screens, sifters, aspirators, flumes, bottle or can cleaners, and X-ray equipment. Let's take a look at a couple control strategies for some physical hazards. Glass from light fixtures can be controlled by using shatterproof light bulbs or shields. Metal fragments from equipment can be controlled by appropriate preventative maintenance, magnets, or metal detectors. Controls for potential metal inclusion in seafood. Monitoring equipment for wear and or breakage. Screening products with metal detectors. Please read Chapter 20 in the Fish and Fishery Product Hazards Guide. Control for potential glass inclusion in seafood. Examination of glass containers for breakage. Please read Chapter 21 in the Fish and Fishery Products Hazards Guide. This concludes Chapter 3. Please complete the following quiz before you go on to the next chapter.